Hi, how's it going? Welcome to Code with Z. In today's video, we gotta find the maximum subarray from this array that we have here. And that's because this is what LeetCode 53 maximum subarray is asking us to do. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're given an integer array called nums, and we need to find the subarray with the largest sum and then return that sum. So we're not returning the subarray, we are returning the sum. Now, if we check this example here, it's gonna make things more clear, but we have it in the slides, so let's check it out there. So we're given this array here, and we gotta return 6. Why 6? Well, because if we actually come up with these numbers, which is basically a subarray that we have here, the sum of these numbers is gonna give us 6. And that's why here, we're returning 6. So we gotta find the maximum subarray inside this array that we have here, and then we gotta return the sum of the elements inside of the subarray. But how do we actually do this? I'm glad you asked. So first of all, let's bring this here like so, and now I'll explain the structure of the algorithm to you, and then I'll visualize everything so you can see with your own eyes how things work. So for finding the maximum subarray, we're gonna need two variables. The first one is gonna be max current. You're gonna see why we need this in a bit. And we're gonna also need max global. And in the beginning, they're both gonna be equal to the first number inside of our array, which is gonna be this -2 here. And you're gonna see why we need these two in the visualization, don't worry. Now, because we need to find the maximum subarray, we gotta basically loop through our array here. So we're gonna have a loop. This is gonna be representing our loop. Anything inside of it is gonna be inside the loop. And it's gonna be a for loop, so we're gonna have a variable, for example, called I, like so. And this I is gonna start from 1, and we're gonna increment it on each round. And the reason it starts from 1 is because here we've already taken care of the number with the index of 0. Max current and max global are already equal to nums at the index of 0. So here we're gonna be like, all right, let's start from 1 because we are already starting from this number with the index of 0. And then inside of our loop, we're gonna say max current is gonna be equal to the maximum number between the current number that we're looping through and max current plus the current number. This one line here is gonna help us find the maximum subarray. Each time we're gonna be like, is the current number greater than anything we've had so far? If that's the case, then let's forget anything that we've had so far and start our subarray from this maximum number. And if that's not the case, meaning if max current plus nums of I is greater than nums of I, we're gonna be like, all right, we think we are on the right path for finding the maximum subarray because max current plus nums of I is greater than this number that we have here in this round. You're gonna see how this works in a bit in the visualization, but all you need to know is that this is gonna help us to find the maximum subarray. And on each round, when we calculate our max current, we're gonna say, is max current greater than max global? If so, max global should be equal to max current. So here we're trying to find the maximum sum, and this is basically giving us the maximum sum on each round, and we want to store that in our max global. Why are we doing this? Because on each round we're going to calculate max current, and max current is going to lose its value. So when we find a large number, we want to store it in something else, right? So we're going to store that in max global, like so. And then at the end, this is going to be everything that we're going to have inside of our loop. At the end, we're gonna return our max global, and this is gonna be all of our code. Now, let's visualize everything together. So when we run this code, we're gonna say first, max current should be equal to nums at the index of 0, and that's gonna be -2. And then we're gonna say max global should be also equal to nums at the index of 0, and that's gonna give us -2. Then we're gonna enter this loop, and we're gonna say, this is gonna be round 1 in our loop. In this round, our I is gonna be pointing to this number because nums of I is gonna be 1, as you can see. And then we're gonna say, max current is equal to max of nums of I, which is 1, as you can see, it's 1, or max current plus nums of I. Well, max current is -2, as you can see, plus nums of I, like so. So -2 plus 1, that's gonna give us -1. Which one of these two numbers are greater? Well, 1 is greater, so we're gonna say max current is gonna be equal to 1, like so, and now max current has been updated. Then we're gonna say if max current, which is 1, is greater than max global, which is -2, update max global to be equal to max current, like so, and now max global is gonna be 1. And then we're gonna finish this round in our loop, and we're gonna enter the next round. As you can see, we are in the second round. In this round, our I is pointing to this number because this is the number with the index of 2. So we have -3. So we're going to calculate max current again. We're going to say max current is equal to the maximum number between nums of I and max current plus nums of I. Well, nums of I is going to be -3. Max current plus nums of I is going to be 1 plus -3. And this is going to give us -2. So which one of these two numbers are greater? Well, -2 is greater than -3. So max current is going to be -2, as you can see. And then we're going to say, is max current, which is -2, greater than max global? Not really. So because this is going to be false, we're not going to get inside of this if statement, and we're going to enter the next round. And now we're going to be in the third round of our loop. Our I has incremented, and now it's pointing to this number that we have here. And then we're going to check our max current. We're going to say max current is the maximum number between nums of I, which is going to be 4, and max current plus nums of I. Well, let's see. Max current is currently -2. So -2 plus nums of I, well, that's going to give us 2. As you can see, 4 is greater than 2. So max current is equal to 4. Now we're going to check if max current, which is 4, is greater than max global. Well, max global is 1. So this is going to be a true statement. And we're going to enter this if statement. And we're going to say max global should be equal to max current, which is 4. And now our max global is going to be equal to 4. And then we're going to enter the next round. As you can see, on each time, we're going to use this line to find the best starting point for our subarray. Each time we're going to be like, if we start from this subarray, would it be better, or is it better to continue what we had? And each time we're going to decide based on that. In this round, our I is going to be pointing to -1. So we're going to say max current is equal to max between -1 and max current, which is 4 plus -1. That's going to give us 3. So between these two numbers, 3 is greater, so max current is going to be equal to 3. And then we're going to say if max current, which is 3, is greater than max global, update max global. Well, because this is going to be a false statement, because 3 is not greater than 4, we're not going to enter this if statement, and we're going to move on to the next round. In the next round, we're going to do the same thing. I has incremented, and we're now pointing to this number that we have here. So we're going to say max current is equal to max between 2 and 3 plus 2, like so. And this is going to give us 5. Between 2 and 5, 5 is better. So we're going to keep the subarray that we've found, and we're going to say max current is equal to 5. And then we're going to check if max current is greater than max global. Well, yeah, max current is 5 and max global is 4. So max global is going to be equal to 5, like so. And then we're going to move on to the next round. Now I is equal to 6, so it's pointing to the number with the index of 6, which is going to be this one here. We're going to find the maximum number between 1 and 5 plus 1, and that's going to give us 6. 6 is greater, so we're going to keep on with the subarray that we have here. If this number was greater, we would actually skip the subarray that we've found, and we would actually move to the newest subarray. But this number is smaller, so we're better off if we keep what we have, right? So we're going to say max current is equal to 6, and then we're going to say if max current, which is 6, is greater than max global, which is 5. This is a true statement, so we're going to get inside of this, and max global is going to be equal to 6, like so. And then we're going to move on to the last round. We're going to check our max current again. We're going to say max current should be equal to maximum number between -5, as you can see, because that's what nums of I is equal to, or max current, which is 6, plus -5, and that's going to give us 1. Between -5 and 1, 1 is greater, so max current is going to be equal to 1. And we're going to say if max current, which is 1, is greater than max global, which is 6, update this, but this is not going to be a true statement, so we're going to ignore it, and we're going to enter the last round. In this round, we're going to be pointing to this number. So again, we're going to check the value of max current. We're going to say it should be equal to maximum value between nums of I, which is 4, and max current, which is 1, plus 4, like so. And we're going to have 5. So max current is going to be equal to 5. Then we're going to check again. Is 5 greater than max global, which is 6? Not really. So we're going to ignore this, and we're going to exit our loop. When we do this, we're going to return our max global like so, and that's going to be everything we need, because max global is equal to 6. And if you remember, the answer of this here was 6. Now let's code this in the simplest way possible. All right, so the first thing that we need to do is to define our variables, just like we saw on the slide. So we're going to say let max current be equal to nums at the index of 0, and then we're going to say let max global be equal to the same thing. And then we're going to have our for loop. We're going to say for let I being equal to 1, and we want to keep on looping as long as I is smaller than nums.length, and we want to keep on incrementing I on each round. Inside of our for loop, we're going to have our important line. We're going to say max current should be equal to math.max, or maximum, between nums of I and nums of I, like so. And then we're going to have our simple if statement. We're going to say if max current is greater than max global, update max global like so. And this is gonna be it. We're gonna exit our loop, and at the end we're gonna return max global like so. I hope I've not made any typos. Let's run this and see if we're gonna get accepted. Moment of truth. And yes, as you can see, all three are passed. Now let's submit it and see if we're gonna pass all of the test cases. And yep, we're passing everything and we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.